All right, so this first section of chapter 19 really introduces evolution to us. And this section really goes over the different scientists that came before Darwin that kind of set the stage for his ideas on evolution. So there's a lot of history behind getting to where we got to today. Um, Aristotle was a Greek philosopher who viewed species as fixed, and he kind of arranged them on a natural scale. He viewed them as unchanging and consistent. And this also kind of went along with the religious belief of the Old Testament at the time that believed that species were each individually designed by God and never changed. Um, then came along a scientist named Carolus Linnaeus, and he is best known for founding a branch of biology called taxonomy, which is basically the branch of biology that organizes and names different species and sorts them into similar groups. He also is the one that developed naming the species. So, for example, Homo sapiens includes the genus and the species, genus Homo, species sapiens. But there's actually, you can go all the way through the classification, and we actually have like 6 names for each organism that all come together. Um, Linnaeus kind of organized the species based on their resemblance of their external physical characteristics rather than anything like genetics or whatnot, because that hadn't been discovered yet. In addition to the grouping of organisms based on similar characteristics and the idea that organisms never changed, we began to discover fossils, which really helped to start open up ideas like Darwin's to become more accepted. So fossils are typically found in sedimentary rock, which appear in different layers. So there were 2 scientists named Hutton and Lyell who believed that changes in the Earth's surface could result from slow, continuous actions, and that basically the Earth is always changing and the mechanisms of change are constant. So similar things are going to happen to the Earth over time, causing its environment to change. And we also realized that with the sedimentary rock, those fossils that were in the lower layers, we could presume were older. And then those we found in more surface level layers were younger fossils. And that was one way that we were able to kind of determine the age where different organisms were prevalent in a particular environment. Then came along a scientist named Lamarck, and he did hypothesize that species evolved through time. So he was one of the first to suggest this change. And unfortunately, his mechanisms were incorrect, but his idea that species change through time, he was really the first one to hypothesize that. But his idea was that species change through the use and disuse of body parts. So the common Lamarck example is the giraffe. So Lamarck basically hypothesized that the reason why giraffes had long necks is because at a point in time, giraffes had short necks. But because they had to maybe reach and get their food source from tall trees, they would keep reaching their necks. And as they did, the use of that body part meant that it was getting bigger and better and closer to perfect. And if, for example, they didn't use that body part, it would get smaller and less useful and eventually disappear altogether. So for giraffes, because they were constantly using their neck, they were getting longer. And then he also believed in the inheritance of acquired characteristics. So basically, once the giraffe kept stretching its neck and it did get longer, it would then be able to pass that trait on to its offspring. And its offspring would be born with the longer necks, even though that had been inherited during that lifetime, acquired, so to speak. This is incorrect for several reasons, which we'll talk about as we move forward. But it should be noted that evolution is never trying to get to the perfect species. There's no perfect species. It's always dependent on the environment. And so that's one of the reasons why we can't support it with evidence. So 19.2 introduces Charles Darwin, who is considered to be the forefront of the theory of evolution and natural selection. And we're gonna talk a little bit about how he got there. So when he was younger, Darwin was always very interested in nature, and after graduating from college, he took a trip around the world on a ship called the Beagle. And as he traveled, he collected lots of specimens throughout the world, but especially in South America. And he started to notice some resemblance between species that lived in the same area, and also some resemblance between species that lived not in the exact same area, but from areas nearby. He did think about Lyell's book, Principles of Geology, which hypothesized that the Earth was more than 6,000 years old, which at the time we didn't think it could be much older than that. And he also kind of took note of some of the geological change he observed by studying the rocks and the fossils, and kind of connected similar appearances to similar changes in the Earth's geological structure. He was especially interested in a group of finches at the Galapagos Island, where he noticed that amongst the Galapagos Islands, many of the finches had very similar characteristics, but they had very different beaks. So this is showing his entire trip. You can see he really traveled all over the world. And then this is a little zoom in on the Galapagos Islands. So he was observing different finches on all of these islands, but he noticed a lot of them were very similar. However, being on different islands, there were different food sources on each of them. And so what he noticed was that different species of finches had arisen. Basically, new species came about, but even though they were closely related, because they had to adapt to the environment where they were. So finches on an island that had a lot of seeds had to have a certain beak, whereas finches that were on an island with a lot of insects for food had a different type of beak. And so he recognized that they all seemed very closely related. You can see these two look almost identical, but their beaks are very different. This one's a cactus eater, a seed eater, and then this finch is an insect eater. So in the 1840s, Darwin wrote an essay on natural selection, but he kind of kept it quiet at first. He was mostly trying to introduce the idea, kind of see where it went. And natural selection is basically the process where individuals with favorable traits are more likely to survive and reproduce. Those traits get selected on by nature, the environment, to be the dominant traits in the group. He also heard from a scientist named Wallace, who had developed a similar theory. And once he heard that, Darwin began working very quickly to complete his theory and write this book on Origin of Species, which is kind of the first of its kind in terms of studying evolution. And if you're looking at numbers, this should be 1858 as well. So it moved very quickly because he was kind of trying to beat Wallace to it. So here's Wallace. He was studying frogs, and he kind of was on the same track as Darwin. So Darwin really explained several observations about life. First, that we are all connected and all share a same common ancestor. Secondly, how diverse species can be and the reason for that. And then finally, the relationship between organisms and their environment. So we'll take each of those in stride. In his original text, he never used the word evolution. He used the words descent with modification, so meaning that organisms changed, but they also passed on similar characteristics as well. But his goal was to show that all organisms are derived and related to each other, and they're all derived from an ancestor that lived in the remote past. So basically, no matter what two organisms you bring together on Earth, they at some point share a common ancestor in the past. So yes, in response to many of your questions, we're technically related to the very first prokaryotic bacteria that ever existed. With Darwin's theory, he basically views life like a tree with different branches, and those branches that are closer together mean the organisms are more closely related. So, for example, these two organisms, these two elephants, would be very closely related, but they share an common ancestor with this elephant from Asia. And then these all three share a common ancestor with the mammoth. And we can actually go all the way back and see that manatees are even related at some point. The common ancestor is more years in the past, but they do share an ancestor at one point. Darwin also noted that humans can modify species by selecting and breeding individuals with traits that they desire, which is called artificial selection. So this would be, for example, like breeding dogs, choosing dogs with traits that you want, and then those are the offspring that get chosen to survive and reproduce. And so he compares that to natural selection, but in natural selection, nature is doing the selecting. So, for example, you could see some of the selection we've done in our vegetables. So he has a couple observations. First of all, he observed that members of a population often vary in their traits. So you can see like all of these are ladybugs, but their spots look different, their heads are different colors, etc. His second observation was that all species can produce more offspring than the environment can support. And so therefore, many of these offspring will not survive and reproduce. Here's an example of a plant releasing a bunch of spores into the air. As you can imagine, there are thousands of spores in this spore cloud. Only a few are going to survive and reproduce. So because of that, there's two inferences that he makes. First of all, he says that individuals whose inherited traits give them a higher probability of surviving and reproducing in a particular environment will tend to have more offspring than other individuals. So, for example, if you live in a snowy environment that's white all year long and there's different variations in fur color, those fur colors that can blend in with the snow have a higher probability of surviving and reproducing, and they will have more offspring than those dark-colored individuals in the snow. Secondly, because there's this unequal ability, because one is better than the other for this environment, those that survive and reproduce will actually accumulate the favorable traits in the population over many, many generations. So you can't really observe evolution happening in an individual. You can only observe it in a population as a whole over a very extended period of time. This was in part influenced by an economist named Thomas Malthus, who basically noted that human population can only increase and to a certain extent, but it will always increase faster than food and other resources. So if you have some traits that are an advantage to you, these will accumulate over time, and then we will see an increase in the frequency or amount of individuals that have those traits. So the reason why certain organisms kind of seem to match their environment, for example, the finches have the correct beaks for the environment they're in. It's because probably at one point there were many different finches with many different beaks, but those that had the right shaped beak for the food source on their island survived and reproduced better and eventually became the more dominant species, sometimes the only one. A couple key notes about natural selection. First of all, is that individuals with certain heritable traits, inheritable is important, they survive and reproduce at a higher rate than others. Also, over time, natural selection can increase the frequency of adaptations that are favorable in a given environment. So over many, many years, you'll start to see a shift in the traits that are present. And then finally, if an environment changes over time, natural selection may result in an adaptation to these new conditions and may give rise to new species. If the species does not have traits that are favorable in the new environment, they will not be able to adapt and we might see extinction. So you can see here the trait of camouflage in effect. There's the bug, and there's another one. So they are able to survive and reproduce in their environment. Once again, a couple notes. Individuals themselves do not evolve, only their populations over a very extended period of time. So you cannot watch one person over their life and say, oh, they adapted and evolved. It would be maybe they contributed to the evolution of the population by having more beneficial traits, but it's often, especially for us, hard to witness evolution in organisms that have a long lifespan like humans because we don't have a long enough lifespan to measure the change over many, many generations. Natural selection can only increase or decrease heritable traits that vary in a population. So if everybody has the same trait, there's none that's going to have an advantage